Good morning, fifth grade online learners. Welcome to March 9th, 2021, where this is our second attempt at this video. The first one froze, and I don't know why. I think I had to take out my trash, but I did that. So, we are learning about the transfer of thermal energy, which is a fancy way of saying how to heat things up. But there's different ways to do it. So the first one is conduction. Thermal energy is spread or transferred through three different processes: conduction, convection, and radiation. Transfer of thermal energy through direct contact is called conduction. Conduction occurs mainly in solids, when rapidly vibrating particles cause nearby particles to vibrate more rapidly. Remember that particles in a solid do not move from place to place, but vibrate back and forth. As they vibrate, they collide with and pass some of their kinetic energy to nearby particles. In this way, thermal energy can spread throughout a solid object or among solid objects in contact with each other. In the picture below, thermal energy from the burner is transferred to the bottom of the pan through conduction. This happens because vibrating particles in the burner pass some of their kinetic energy to the bottom of the pan. As the process continues, thermal energy is conducted throughout the pan and into the food it contains. The pan and its contents become warmer. So conduction is thermal energy from the burner is transferred through the metal by conduction. It happens when particles transfer their vibration to neighboring particles. Fancy way of saying we're heating up some food. Okay, conduction, heating up food. Now the example they give for convection also happens in this room in the aquarium, because I have a heater in that tank for all the fish, and then there's filters that circulate the water, and when the water circulates, that's called convection. Yes?
Do you have a heater in your fish tank?
Yes. Yeah, right by, there's a pirate ship and there's a skull, it's behind the skull. But there are two filters, and they get all the water, they circulate it, and we have convection, and it keeps the fish warm. As you have learned, gases and liquids are not rigid like solids. Their particles move much more freely. When a gas or liquid is in contact with a hot object, it expands and becomes less dense as its temperature increases. A warmer, lighter liquid will rise when the surrounding cooler, denser liquid will sink. This process is called convection. Convection is the process for transfer of thermal energy in liquids and gases. The aquarium above uses a heater to warm the water. Water becomes warmer as it touches the heater, causing it to expand and rise. As the warm water rises to the top of the aquarium, it carries thermal energy with it. Some of that energy is transferred to other water particles by collisions. When the warmer water reaches the surface, it continues to lose thermal energy to the surrounding water and the air. As the water cools, it becomes denser and sinks. Eventually, it reaches the heater and starts the journey again. So in the picture, they show red and blue arrows circulating, and that is convection. Okay, and the last one is radiation. That's on page F90. Thermal energy can also be transferred by radiation. Radiation is the transfer of energy by electromagnetic waves. All objects emit thermal radiation. Even the Earth's polar ice caps emit a little. Living things, including your body, emit some radiation. A hot burner on a stove emits much more. When an object absorbs thermal radiation, its particles vibrate faster. This increases their kinetic energy and raises the temperature. Here on Earth, the most important source of radiation is the sun. The sun emits radiation of different wavelengths. Some are waves of visible light. Others are infrared light, which have a longer wavelength. Most of the heating power of the sun comes from infrared radiation. A campfire is similar in some ways to the sun, only on a smaller scale. Both emit waves of visible light in infrared light. After sunset, the campers will use the fire as a source of light and heat. You feel infrared radiation as heat because the specific wavelengths of this radiation affect the motions of the particles of your body. Longer infrared wavelengths cause particles to move faster and increase their thermal energy. Shorter wavelengths, such as those used in remote control devices, do not cause particles to speed up very much, so they do not increase thermal energy. All electromagnetic waves carry energy. Matter can absorb some of the waves in infrared, ultraviolet, and visible light. Any waves that are absorbed will add thermal energy to whatever absorbs them. This is the reason certain colors of clothing feel warmer or cooler on a hot summer day. Lighter colors reflect more solar radiation than they absorb. Wearing light-colored clothes will keep you cooler. Darker colors absorb more solar radiation than they reflect. Wearing darker colored clothes on a cold, sunny day will keep you warmer. Ultraviolet rays are electromagnetic waves with shorter wavelengths than visible light. The rays penetrate your skin and are absorbed. Too much UV radiation can cause a sunburn. This is why you should wear a sunscreen or to block out the UV rays. Fortunately, a layer of ozone in the upper atmosphere blocks much of the sun's UV rays. Even so, a certain amount of radiation always passes through. And in the picture, they show a girl putting some sunblock on her nose. That's an area that tends to get sunburned more so than others. So, not that the rest of your body won't get sunburned, but your nose does, for some reason, seem, maybe it's because your skin's a little bit not as thick in that area as maybe some other places. All right, so we'll continue our discussion tomorrow, but 5th grade online learners, please make sure you do your journal entry for today, Wednesday, and Thursday. Also, study your study guide. Get ready for Friday's quiz. And we will see you tomorrow. Bye-bye.